Okay, before we talk about some of the major aspects of dental materials, I just want to give few important things that you have to make a note regarding your overall preparation. Okay, right? So, I was into this field 10 years back. So we are done with 10 batches. Now we have started the 11th batch. And I personally have interacted with so many students, personally monitored their preparation very closely. I used to interact with them. I used to guide them. I used to modify their preparations. And I made so many students to achieve their ranks and get settled in their life. So overall, after 10 years of work, so my suggestions, okay, let it be you consider it in the middle of the preparation, or let it be you consider very early phase of the preparation. Okay. So my suggestion for all of you is, okay, get prepared. Okay. So your preparation is very important in the last 3 months. Last 3 months, what you are doing is more important. Something like, for example, in the home, or you're going out and you're planning to cook. Okay, you're planning to cook, and finally you want to eat. Okay, so something like whatever you cook, you want to eat it. So you're going to eat on the day of exam. You're going to eat on the day of exam. I want to make it so simple. Okay, so you cooked a lot. You want to eat it on the day of exam. So for example, eating for a dinner or eating for a lunch is an exam. What exam? Final exam. You consider this as a final exam. And whatever you're going through the process of cooking, okay, means, for example, you started the preparation, arranging everything. Means you went to market, you're going to arrange everything. Cut the vegetables, do it. Okay, start the cooking process. Okay, so individually, every item you're going to cook. Individually, every item in the sense, every subject, every topic you're going to cook. Okay, and in the middle, you're going to taste it. Taste is nothing but taking an exam. Exam is going to tell you how much good the cook is, whether the dish is nice or not. So for every dish, you're going to taste it and you're going to decide, okay, this is okay. I need to do some modifications. I need to upgrade it. So similarly, what you're going to do, okay, so now I am going to prepare a plate. The plate is going to have all the meals, okay, which I will taste and I will arrange and I'll prepare it for the final exam. This is how it is going to be. So in this process of cooking, so what do you feel the most important step is? The most important step in the process of cooking is, okay, the most important step is finally you are giving the final exam. Okay. So every step here, it is very, very important. How you organize, how you prepare yourself, how you do the modifications in the preparation, how individual ingredient is nothing but individual topic. Okay. Every topic of a subject will make a dish. All the dishes on the plate should be there in the examination hall. Whenever all the dishes are properly arranged, properly made, you will be success in the examination center. You'll be having the success in the examination hall. So this is very, very important. Okay, right? So my concern, like, let it be an intern, let it be a repeater, let it be a housewife, let it be any one of you. Okay, different levels, different ideologies of preparation. The most important thing is here, respecting every step. Let it be you have an off, you're not feeling well, you took a break of 2 or 3 days, it is okay, no, not an issue. But again, I want you to cook each and every ingredient properly. Every stuff should be cooked well. You have a break of 7 days because of a college event or a college fest, it's okay. It's okay, you can come back, you can bounce back. Please don't write on my screen. Again, I'm repeatedly telling, please don't write on my screen. You have to wait. Yeah. So, so most important aspect is, like, every aspect, every stuff, everything, whatever you organize is more important. That is first and foremost thing I want you to suggest. The second important aspect that I want you to stress on is, Okay, first try to finish the app content. Okay, then you think about dental pulse. Doing dental pulse is not at all wrong. Doing any other book is not at all wrong. Okay, but first the app content has to be done. Once you are fine with the app content, once you are able to manage the time with the app content, then you can think of solving any other XYZ book. I hope this is very, very clear. The other important aspect I want to add a note is whatever extra things that you are learning from extra source, let it be in a WhatsApp activity. You learn some new things. Yesterday, we have discussed something new in the WhatsApp activity. Make sure that should be converted into notes immediately, and that should be added to your worksheets. For example, you're solving MCQs on the web. Okay, please do mark them. Whatever you find new things, do mark them, do review them, do mark them, and do demarcate them. Because reading again everything, whatever you have done in the last 3 months is very, very important. Clear? Or else you're doing dental pulse. You find some new questions out of like 100 questions, whatever you have solved from a different source. You find 30, 35 new questions, new concepts. Please do write notes for those new concepts and add to the worksheets. Because last 3 months, you get confused where to be done, how to be done. You have done so much of things from different sources. Everything will get overlapped and it's going to spoil your party. Okay. It is something like you cannot add ingredient of biryani to ingredient to chicken curry, right? I told you, right? Dishes, everything should be done properly. Dishes, everything should be cross-checked properly. Dishes, everything should be arranged properly. When they are arranged properly on the day of meal or on the day of exam, then only you can execute them, eat them well, and you get best out of that. You got it, right? So that is the reason why I try to compare it to a properly well-organized meal which is being prepared by you. So everything should be organized well. So whatever you want, please do add it to your notes. So it is organized. You don't tell that I'm going to do this from the, it's okay with one subject. Is it okay with 22 subjects? Because you are going to handle 22 subjects in the last 3 months. And you're going to handle 22 subjects revision part in the last 10 days before you're going to exam. So it's not going to be that easy. Okay. Most of the people fail not in preparing for the exam. They fail in executing in the examination hall because their revision or their quick revision is not proper. Things will get overlapped. One subject, one topic per day. Yeah, so cool. Everyone can handle it. But if I'm talking about multiple subjects, multiple concepts, all them at a shot, you have to read 22 subjects at a shot. It's not going to be that easy. Okay, clear, guys? So this is very, very important suggestion. I want you guys to make a note. Okay, and that too, subjects like DM is going to be tough. Subjects like biochemistry, it's going to be tough. I'm telling itself, now itself. It's going to be tough here. It's going to be tough to understand. It's going to be tough in the final exam also to recollect. So these subjects has to be done repeatedly. Dental anatomy, you have to do repeatedly. Dental histology, you have to do repeatedly. General anatomy, you have to do repeatedly. Pharmacology has to be repeated so many times. DM has to be repeated so many times. A part of community has to be repeated so many times. Biochemistry has to be repeated so many times. And general medicine has to be repeated so many times. So these are the toughest subjects. I'm telling openly, these are going to be tough. These are not comfortable. You read them simply, you cannot understand. You need to keep lots of hard work to understand those things and lots of hard work to revise and retain those things. Again, application part question. Question is not going to be straight away. I'm not going to give what is the example of ionic bonding. Such a questions, yeah, they will be there in the examination hall, but you need to apply whatever you have learned here to come out with the right answer in the examination hall. So that practice is also required. When this is going to happen is everything arranged on the table properly. Like you see my working table, everything is arranged. Lights are there. Okay. Mic is there. Laptop is there. Tab is there. Connectors are there. Electricity is there. So everything is arranged properly. So when everything is arranged properly, only I can execute the class. That's what the disturbance today, right? My internet is not stable. So there is some disturbance, small disturbance, a very small disturbance. Okay. I have 20-25 things arranged properly, but internet is not working. Class is getting crashed. So that is how the examination is going to be, right? Clear, guys? Very important. Connectivity is very, very important. Organizing is very, very important. Dentistry requires organizing and your preparation requires organizing, right? Everything. Base, what is the thickness? Liner, what is the thickness? Upon which, what I'm doing, I'm keeping a restoration. What is its thickness? Am I doing polishing and finishing to the restoration? Am I waiting till the restoration set? So everything plays a vital role for the success of your restorative procedure and success of your preparation. I want your response on the chat box so that I can go ahead and try to explain few important concepts in your DM part. Clear? Yeah, I want response. 80 people, 80 odd, 100 odd people are there. Nice. Nice strength. Quick response. High energy levels has to be maintained in the examination hall. You should have that high energy levels always. So I'll try to brush up few important concepts of DM for a half an hour, basing upon the convenience. So first and foremost thing is interatomic bonding, which we have already discussed. So interatomic bonding is basically divided into primary bonding and secondary bonding. Right, and we have already discussed primary bonding. The most important characteristic feature of primary bonding is what? The most important characteristic feature of primary bonding is what? The most important characteristic feature of the primary bonding is presence of electrons. Electrons will be there. Electrons has some role. Whereas when you're talking about the secondary bonding, there is no role of electrons. Okay. So primary bondings are basically divided into ionic bond, covalent bond, and metallic bond. And examples which are given in your dental flips are very, very important because most of your DM questions will be straight away taken from this book and repeats. So ionic bonding examples are gypsum and phosphide-based cement. Covalent bond examples are dental resins, and metallic bond examples are all metals. Van der Waals forces of attractions are present anywhere. Like whenever you stand, you and me are standing together. The forces which are present are Van der Waals forces of attraction, and hydrogen bonding is present in water, H2O. Okay. So this is what the diagram that is given in your dental Phillips textbook. So first of all, I'm talking about the primary bonding. The first heading is ionic bonding. So ionic bonding basically moves on transfer of electrons from one element to other element. That is what happening here. The best example is Na plus Cl. So there is a transfer of electron. So there is a transfer of electron. So this is called as ionic bonding. The second one is covalent. Covalent means they're sharing together. So covalent bonding is basically shared electron. The next one is metallic bonding. I already told metallic bonding, the most important keyword that they regularly use is cloud of electrons. So you have electrons that are moving. So these electrons are basically useful for the conduction of, let it be the electricity or let it be the heater or thermal. Okay, whatever it is. Okay, so metallic bonding is basically characteristic by you will be having electron sharing and you will be having the formation of cloud of electrons that are bonded to the positive charge nucleus in the lattice. You can see this is a lattice where you can see cloud of electrons in the lattice. Where you can see crowd of electrons in the lattice. Clear, right? So they can ask you a diagram-based question over this area also. Okay. Clear, right? So three types of bonding are very, very important. Electron. So three types of bonding. One is primary bonding. Primary bonding, which is going to include guys, please don't message me when class is going on. Please. Don't message me when the class is going on. Please, please, please. Because I'm already using my mobile data. I told you, right? This is just a half an hour class. Now it is it's turning to 1 hour. Unnecessary waste of time of you as well as me. You have entire day to discuss with me. Suddenly you will get motivated to talk. Hope the screen is visible to you. Okay, right. So these are the three diagrams that you have to make a note. Examples are important and the mode of electrons, how the electrons are playing. One is transfer of electrons. Second one is sharing of electrons. Third one is sharing plus cloud of electrons. Okay, that is happening in the metallic bonding. Then comes to the secondary bonding. Secondary bonding, basically, you're not going to have any sort of sharing of electrons, okay, or any sort of electrons will be there, okay. And secondary bonding examples are, one is van der Waals forces of attraction, and the second one is hydrogen bonding will be there. So of course, I have discussed this van der Waals forces of attraction also for you. So van der Waals forces of attraction are basically happening by dipole attraction. Okay, that is happening by two methods. One is polar, second one is non-polar. I told you to remember P for P. P for P, polar, polar for permanent. Okay, so what happens in the polar compounds? So in the polar compounds, there will be attraction and repulsion. Okay, so what is going to happen? A molecule will be splitted. So you can see the yellow one here and you can see the green one. Okay, so or else it can be considered as a north pole and a south pole, or a positive charge or a negative charge. So yellow is going to repel, whereas yellow green are going to get attracted. So it is going to have an attraction as well as repulsion between the molecules, which is basically induced by the permanent dipole. Okay, and this distribution is asymmetric distribution. So that results from asymmetric electron distribution within the same molecule. You can see one big side and one small side. So that is asymmetrical electron distribution. This is a permanent dipole. So we have discussed polar is permanent. Polar is permanent. The second one is non-polar. We have discussed the second one is a non-polar one. So the non-polar is basically happening by temporary. Okay, P for P, polar is permanent, non-polar is temporary. Non-polar is temporary. So what happens in the non-polar? Non-polar, there may be symmetric or asymmetric distribution that can occur. Okay, symmetric. Okay, so non-polar bonding is basically by temporary dipole, that is basically fluctuating dipole that occurs with symmetric distribution of electrons in a molecule, which slowly become asymmetric temporarily. So that is the reason why it is called as temporary dipole. That is the reason why it is called as fluctuating dipole, because at one point it is symmetrically followed by it is turning into non-symmetrical. So clear, right? This I have already discussed. So these are the two different types in the case of van der Waals forces of attractions. Yeah. Then comes what is the second part of your secondary bonding? The last category, the second part of your secondary bonding is hydrogen bonding. Hydrogen bonding that most of us are familiar. It is present in the water. So water H2O is going to contain both covalent bond as well as hydrogen bond. Okay, clear? This we have already covered, and you have the basic knowledge. Okay. The next one, most of you are confused about this particular graph, stress strain graph. Okay. So I'll try my best to make it as simple as possible. Stress strain graph is very, very important from examination point of view. So to understand dental materials, physical properties or mechanical properties, we should have a decent, strong knowledge over physics and a little bit of mathematics that most of us are weak. We have to accept it. But I mean, to understand what is basically happening here, to understand the basics, you don't require physics and mathematics. You require some logics, and you require to understand the concepts, to mug up the concepts, at least few concepts. So stress strain graph we are discussing from the 11th standard. And stress we have already discussed. The formula of stress, simple formula of stress is force by unit area. Force per unit area means, for example, I'm taking an object. Okay, what I'm doing, I'm applying the force on that object. I'm applying a force on this object. So what is happening? So that there is internal force in this object which is resisting my external force. That internal force is called as stress. So internal force F by unit area. How much the unit area is there? So internal force, what is present inside, plus the entire area is basically called as stress. Stress is basically defined by the internal force which is opposing the external force by unit area is called as stress. Clear? Okay. Then comes to the second statement called as strain. So what is the strain? Strain is change in length by original length. Initially, the length is L1. So what is happening? So this object, I'm trying to compress it. It is getting compressed. So it is getting small. Okay. So initially it is L and finally it is L2. Or I'm expanding it. Initially it is L, finally it is L2. So what I'm doing is L2 minus L1 by L1. L2 minus L1 is nothing but difference, change in length by original length is called as strain. I hope you got it, right? So now you got the difference between what is stress and what is strain formula wise. So now what I'm doing, I'm taking a material. For that material, what I'm doing, I'm trying to draw a graph between stress and strain on x-axis and y-axis. So what happens? As it starts at a point, okay, the stress increases, the strain increases, stress increases, strain increases. Means you have a straight away line that is clearly telling that stress is directly proportional to strain. But at one point, it stops. It is this proportionality is not happening. If it is happening, it should be like this. It should go like this. It is not happening. Means up to a particular point, the stress will be proportional to strain. After which, the theory varies. Okay. Stress directly proportional to strain is called as which theory? Any law is there? Anyone? Any one of you? Stress directly proportional to strain within elastic limit is called as Hooke's law. Very good. So at up to a particular point, Hooke's law is being maintained. What is Hooke's law? Whenever you stretch something and leave it, going back to its original thing is called as Hooke's law. That is nothing but stress is directly proportional to strain. Right. So here I want you to make a note. Okay. So there is something called as proportional limit. What is this proportional limit? PL. Proportional limit. I'll try to explain the same content from the textbook diagrams also, because examination, they're going to give the textbook diagrams straight away. So proportional limit, stress is directly proportional. The greater the stress, greatest stress is at this point, where stress is directly proportional to strain is called as PL. That is proportional limit. You got it, right? You got it? So stress is directly proportional to strain is called as proportional limit. Okay. So after proportional limit, please do mark one more point. After proportional limit, please do mark one more point. This point is called as yield strength. I'll tell you what is yield strength. So normally what I'm going to do, I'm keeping an exam. Okay. And yeah, for our examinations, you have 50% is the qualifying score, right? So your theory exams and everything, out of 100 marks, how many marks you should get? How many marks you should get to pass the exam? You should get 50 marks to pass the exam. But there are few students who got 48, 49. So I'm giving some extra benefit for those students. Okay. People who got 45 to 48, or 46 to 48. Okay, come, I'll add some score and I'll make you pass. Okay. So what yield strength is something like a little bit of standard deviation I'm going to add. That is basically called as offset. I'm going to add some offset. Let it be 0.1% in few conditions. Let it be 0.2% in few conditions. So I'm going to give some extra benefit, okay, by which I'm going to create an offset. So for example, if I'm leaving something, PL I'm leaving, okay, the PL is going to come at this point because stress is directly proportional to strain. So what is happening? Your yield strength will not come at this point. So yield strength is going to come somewhere here. Okay, this is called as offset. So that offset can be 0.1 or 0.2%. Okay, means there will be, what is the definition? Stress at which the material exhibits a little deviation from PL. You got it right? This is PL. PL, this is the PL deviation. So what is happening? Your yield strength is also PL, but a little bit of standard deviation. There is some sort of deviation. Okay, so there is a limited standard deviation. You got it right? Guys, you got it, very important. So they're going to mark this stress and strain graph, different points, and they're going to ask what point this is, what point this is. Okay, clear? I hope I'm audible to you. Please do respond me on the chat box. You got it right? What is PL and what is yield strength? Okay, so PL is a point. Okay, so PL is a point before which the material is going to behave, or the material is going to have elastic properties, after which the material is going to have plastic properties. Okay, right? So all this area is elastic area. So all this area is plastic area. Okay, so PL is the one which is differentiating the elastic area to that other plastic area. Whereas I'm telling yield strength is in which area? It is in elastic area or it is in plastic area? Where is yield strength? Is it yield strength elastic area or plastic area? Where is yield strength? Yeah, yield strength is in the plastic area. Okay. Whereas PL is a point before which it is elastic and after which it is plastic. Okay. Now I'm talking about a continuation of this. Okay. So now I'm talking about Young's modulus or elastic modulus, they called it as. What is this Young's modulus of elastic modulus or modulus of elasticity, MOE, is this by this. Okay. It is simply stress by strain. Got it right? Simple formula. So x-axis by y-axis is called as MOE, modulus of elasticity, or Young's modulus of elastic modulus. What is this modulus of elasticity basically telling? The modulus of elasticity is telling that there is a relative stiffness of a material which is measured by the slope of elastic region of stress strain graph. What is the formula for slope? A little bit of mathematics. Anyone remember what is the formula for slope? What we have discussed during our 11th and 12th standards, 10th class also. Slope formula is x-axis by y-axis. What is present in x-axis? Stress is present in x-axis. What is present in y-axis? Strain is present in y-axis. So Young's modulus is nothing but slope. Formula of slope of elastic region of stress and strain graph. So that is nothing but stress by strain. What is this Young's modulus is telling? The Young's modulus is telling the stiffness of the material. Stiffness, very, very important point to be noted. It is talking about the stiffness of the material. Okay. Now my question for all of you is, because we have done this during our 10th, 11th, and 12th. Okay. So there is one statement. Modulus of elasticity is high for stainless steel compared to rubber. True or false statement? Modulus of elasticity is high for stainless steel. Modulus of elasticity or Young's modulus is high for stainless steel compared to rubber. It's true or false? Yeah, I hope you guys remember this. Yeah, that's a true statement. Okay, true statement. Stiffer materials are going to have more modulus of elasticity. So you can remember the statement what we have done. So modulus of elasticity is more for stainless steel compared to rubber material. Stiffer materials are going to have more modulus of elasticity, whereas flexible materials are going to have low modulus of elasticity. Now I'm talking about an INICET question. Modulus of elasticity is high for enamel or dentin? Modulus of elasticity is high for enamel or dentin? Yeah, that's what your question. If you start solving dental bills, you'll find this question. Modulus of elasticity is going to be high for stiffer material when compared to elastic material. The answer is enamel. The answer is enamel. You can write down the units of modulus of elasticity, which are same as the units of stress. Because strain, does strain have a unit? Does strain have an unit? Yeah, strain is not having a unit because it's a ratio of length by length. Whenever you're ratioing length by length, the units will get cancelled. So strain is not having a units. So stress by strain, it is a units of stress. That is newtons per meter square. Newtons is the unit for formula. Sorry, is unit for force and by meter square. It can be called as gigapascals or giganewtons by meter square. You got it right? Simple. Not too complicated mathematics or physics. Basic mathematics and physics I'm trying to teach you. Right. So tell me what is the formula for modulus of elasticity? What is the formula for modulus of elasticity? Yes, it is stress by strain. Yeah, very good. Tell me the formula for stress. Tell me the formula for stress. Stress is force by unit area, F by A. So tell me the units of strain. Tell me the units of strain. Strain has no units. Yeah, very good. So sometimes you require no need to go very deep into the concepts whenever you're preparing for entrance examination. Okay, no need to go very deep. Sometimes you need to go deep into the reading aspects. Okay, so you have to differentiate that line of demarcation whenever you're preparing for an entrance exam. The next one is, I want you to make a note, one more important thing. G is equal to 0.38E. G is nothing but Shear's module. G is nothing but shear module is 38% of elastic module. Shear modulus is 38% of elastic modulus. So that is called as G is equal to 0.38 ratio of E, where G is shear modulus and E is elastic modulus. Please do remember this formula and remember this value of 38%. They can ask you a question. Hope you can see this graph. Okay, here you can see this graph. So I'll try to mark the points. I want you to tell the answer. So point at which your elastic property is going to convert into plastic property. What is this point called as? What is this point called as? PL. Clearly visible. You have PL there. Okay. Then I told you there will be some standard deviation. Okay. Some offset I can provide you. A little bit of deviation from PL. So that little bit of deviation from PL, one point is there. What is that point called as? Yes, you got it right. That is yield strength. That is yield strength. Now there is one more point called as ultimate tensile strength. One is yield strength. Second one is ultimate tensile strength, is a point at which the material is going to rupture. The material is going to break. Ultimate. What is ultimate for us? Ultimate is a point before the death. That is the ultimate thing for us. Okay, right? So ultimate tensile strength is a point where it is going to break. Now tell me, here they have calculated some E. What is this E? What is this E? Just trying to understand what is elastic modulus. What is the formula of elastic modulus? We have discussed stress by strain. Stress by strain. So this value is stress. This value is strain. And overall, you got a value. The value is having GPa, gigapascals. Got it right? Simple. Just try to understand the concepts. It's not too heavy. Yeah, but it is a little heavy for a dental students to understand for the first time. So once you understand, you can return them for a longer period of time. Next one is, this also most of you are familiar. So this is resiliency, is basically the amount of energy per unit volume that is sustained on loading and released upon unloading a test specimen, or this is basically called as springiness. Springiness of a material. It is the amount of energy that is absorbed within a unit volume of structure when it is stressed to its proportional limit. And whenever you relieve it, it's coming back by releasing that energy. Got it right? It is basically S-E, R-E-S. E for energy. S for springiness. Clear? If you're fine, we'll go to next topic. Okay, I hope you guys have a better idea now about these graphs and everything. So I hope you can answer a few more questions. Okay. So this is what your textbook is giving. So textbook is giving. So we have discussed about PL. Right? We have discussed about PL. And we have discussed about elastic strain. Before is called as elastic strain. After is called as plastic strain. And whatever energy that is being stored, energy is basically calculated like this. The energy before the elastic property is called as resiliency. We have already discussed, right? E for energy. This is one more graph in your textbook. I told you, right? I'm going to give an offset of 0.2%. Okay. So P is proportional limit. E is yield strength. Y is yield strength. Ys is yield strength. UTS is ultimate tensile strength. So I am giving an offset of 0.2%. Can you see the value? 0.2% offset I am giving. So there is some sort of deviation from PL. That deviation is called as yield strength. Clear? So you can clearly see they have given a 0.2% of strain offset from the original O value. The O value is basically useful for PL. 0.2% is basically O value is useful for PL. 0.2% is offset is useful for YS. That is yield strength. Clear? 99% is they're going to give a textbook based diagram itself. Sometimes they can give a Google based diagram, but the concept is similar. Okay, if you're done, I'll be going to one more important topic. Okay, right. Right. We have already discussed stress is force per unit area. Strain is change in length by original length. Shear stress is V by D. Okay. And I hope you guys have seen this. Okay. Again, this is a very, very frequently asked diagram-based question for us in DM, physical properties. So on one area, what I'm doing is I'm taking strain. And on one axis, I'm taking stress, that is shear stress. Okay. And I'm plotting a graph. And now I have different sorts of liquids or materials which are used in dentistry here. I'm going to discuss them. So first I'm going to discuss something which is common. Okay. What is common? Idle. What is idle? Newtonium is idle. Okay. So newtonium is also called as an idle liquid or idle material, where your flow index for this is going to be 1. So what is this following? This is following stress is directly proportional to strain. So you can see it is starting at the common point, and you can see it is straight away growing. It is growing. Stress is directly proportional to strain. That is called as Newtonium. Ideally, 1. Ideally, Newtonium flow rate is 1. Formula is stress is directly proportional to strain. So you see the graph. Anything that is starting from the starting point and it is proportionally growing, that is called as Newtonium. Clear? Okay. Then next one is pseudoplastic. Okay. Pseudoplastic, where your flow index is less than 1. So what happens whenever there is increasing in stress? Whenever there is increasing in stress, okay, there is less increasing in strain. Okay, but it is increasing. So you see, increasing in stress, increasing in strain will be like this. But increasing in stress with increasing in strain, decreasing in strain, less increasing in strain, this. Okay. because normally it has to go like this, but it is increasing, but not drastically increasing. The increase is less. So whenever there is increasing in stress, there is less increasing in strain. That is called as pseudoplastic. What happens with the pseudoplastic? The pseudoplastic, their viscosity is going to decrease and the flow is going to increase. Okay, so what is going to happen? It's more like in a liquid. Okay, flow is increasing, viscosity is decreasing up to a particular point where it is going to become constant. That is called as pseudoplastic. So pseudoplastic opposite, you can remember DP. D is opposite to P. D is opposite to P. So D is opposite to P. How P is going? P is going like this. D is going like this. So these two are opposite. Okay. So whenever there is increasing in stress, whenever there is increasing in stress, what is happening? The flow rate is more than 1, opposite to P. So D and P are opposite to each other. So this is P. So this is D. They are opposite to each other. So whenever there is increasing in stress, the more increasing in strain. Normally, whenever there is increasing in stress, the strain should increase. But here it is increasing more. There previously P, there it is decreasing more. Okay. So in such conditions, what is going to happen? The flow rate is going to decrease. The viscosity is going to increase. So there, the liquids are going to become more rigid. The liquids are going to behave like a solid because the viscosity is getting increased. Okay. Then comes the last but not the least is plastic. What happens with plastic? Plastic is following the principle. It is a straight line, but the straight line is not starting from a 0 point. 0 point is this. So plastic is having some offset. We have already discussed about the concept of offset. What is the concept of offset we have discussed? Offset concept is clearly telling that I'm not starting at the starting point. Okay. So because I have discussed the concept of offset here also, because here I'm not starting from the starting point. Starting point is 0. So I am starting from 0.2. That is my yield strength. So it is not following the offset. It is having an offset of 0.2. Here also in this area is basically called as offset. So what happening in the plastic? Stress is directly proportional to strain. I'm happy with that. Lucky. But I'm not starting at this point. Okay. I'm not starting at this point. I require a push. I require a push to start. So what happens here? Some materials exhibit rigid behavior until they reach a particular stress point. After reaching that stress point, the materials are going to start behaving in a pattern that is required for us. Okay. So offset is present in plastic materials only, whereas rest of the materials, the offset is not present. Why the offset is not present? Because all the other materials are starting from 0. This is the only material which is starting with an add-on offset. Clear, right? So now I hope you can answer this diagram based question. So INICET, what previously have given, they have given this color coding of lines on a graph, mentioning it as A, B, C, D, and ask you to identify what is A, what is B, and what is C. Clear? Now you got a basic concept. Which two are opposite to each other? Which two are opposite to each other on the graph? DP, display pic, easy to remember. P for pseudoplastic and D for, you got it right. So D and P are opposite to each other, which is ideal, which is exactly following your properties. Neutral, you can remember it as newtonium, neutral. You're in neutral. Neutral means following. Ideal is neutral, newtonium following, and N value is 1. Stress is directly proportional to strain, which requires some motivation. Like we always want to prepare, but we require some motivation. The plastic materials, they require some motivation. They have an offset. Okay. And coming to stress strain graph, where do you use 0.2% as offset? For what strength you are going to use 0.2% as offset? Yeah, that is called as yield strength. Very good. Now I'm trying to, let it be, my DM can be full of numbers. Okay. Dentistry is all about numbers. Do you accept it? Thickness of base, thickness of liner, thickness of restoration, how much reduction of functional cusp beveling has to be done, how much angle it is, how much reduction has to be done, centric how much, non-centric how much, what angles you give. So dentistry will move around numbers. Okay. So please do get adapted to the numbers. Try to learn the numbers, not all numbers, but whenever you encounter numbers, you try to learn the number and try to understand the number. Okay. Right. Now, I'll just try to, because this is again a table from your dental pulse. Density, thermal properties of enamel, water, dentin, and few dental materials. Okay. Right. The first column is telling you about the densities. So density of water that most of us are familiar is 1. Okay, density of the water is 1. Then you jump into density of enamel, 2.97. Don't come and ask me. If you check out your Orbans, which we are going to do in dental histology, the answer will be 2.8 or 2.9 or 2.8. Just accept it. Okay. Then density of dentin, again in Orbans, it will be 2.2. Okay. It will be 2.2, 2.2 or around like 2 to 2.2. Okay. So density of dentin is very near to GIC. Density of dentin is near to GIC. Okay, you want to add any statement here? What is the other name of GIC? Any name of GIC is there? Any name is given to GIC? Right, very good. GIC is called as man-made dentin. It has a properties. Okay, it has a properties related to dentin. Okay, so you can see the density values of dentin and GIC are same. So that is the reason why, this is one of the reason why the dentin is called as GIC is called as man-made dentin. Okay, right. Of course, again, zinc phosphate, I'm going to keep in the place of dentin. I'm going to use it as a base. Okay, it also have a closest density value. Okay, right. When coming to the composite, it is very close to both enamel as well as dentin. And of course, the values of amalgam and pure gold are important. Okay, gold is 19.3. The density value of gold is a very frequently asked question. It is 19.3, whereas density of amalgam is 11.6. Specific heat values are not much important. You can ignore them. Okay, are not much important. Rest are not important. The only column where the questions are coming from is density. Apart from this density, I want you to make a note about the density of nitrous oxide. Anyone can answer density of nitrous oxide, which is used in consistidation? A very common, frequently asked question for us. It is 1.53. 1.53. Okay, right. Okay. Next, again, these numbers are slightly important. Let's learn about the concept. Okay, what does the concept is telling? So whenever I have anything, so whenever I heat it, whenever I'm heating it, so what is going to happen? Any object, whatever I heat, like for example, I have this thing in my hand. So I'm going to heat it. So what is going to happen? There will be some expansion that is going to happen. So lengthwise, it is going to expand. Volume-wise, it is going to expand. Okay. So this sort of expansion is called as coefficient of thermal expansion. Coefficient of thermal expansion value is going to tell you that anything is going to expand upon heating. How much expansion that is going to happen is going to be the coefficient of thermal expansion value. Okay. So that's what this coefficient of thermal expansion value of a dental materials compared to the teeth they have given. Because all these materials will come associated with the teeth. Do you accept it, right? So I'm keeping an amalgam registration. So in my teeth, so class 2 amalgam or class 1 amalgam, nicely I have done. So what is going to happen? The patient is going to go, after a few days, the patient is going to take a hot coffee or a tea. All of us have a habit of taking hot tea, right? Do you accept it? So what is going to happen? This is my class 1 registration. So I have amalgam filled in it. So what I'm going to take, what I had done, I have taken a hot tea. So whenever I take a hot tea, you accept that amalgam is going to expand a little bit. Similarly, my teeth are going to expand. My teeth is also going to expand. Do you accept that? Both of them are going to expand. Do you think expansion of both of them is same? It is never. Okay, you see the coefficient of thermal expansion of amalgam is 25. It expands with 25. Whereas a coefficient of thermal expansion of a enamel is 11. Okay, enamel is 11, amalgam is 25. Means it's almost double. Okay, so which is going to expand more? Enamel is going to expand more. Sometimes enamel is going to break and come out also. Okay, right? So what happens? There is some property called as hygroscopic expansion. Okay, amalgam is having a delayed expansion, right? So what is the delayed expansion? The delayed expansion is basically due to zinc. Zinc is going to react with water in 3 to 5 days time period after the restoration, and it's going to form ZOE plus hydrogen. The gas, in order to come out, okay, is going to expand, and the tooth sometimes breaks or the restoration sometimes break. This can happen whenever there is high exposure levels of heat to amalgam also, because the expansion rate of amalgam, the coefficient of thermal expansion of amalgam is not same as that of the teeth. So what is the concept that is happening? So what is happening is whenever I take a cold object, so there will be contraction. Whenever I take a hot object, there will be relaxation. So always, if you consider this as a tooth and this as a restoration, so there is always a gap of interference is there. Okay. So because of contraction, the gap is created. Because of expansion, the gap is closed. So what happens? There will be movement of fluid inside and outside whenever there is change in temperature. Contraction, the fluid come inside. Okay. Normal temperature, the gap will close, the fluid go outside. This movement of fluid inside and outside is called as what? The movement of fluid between the interface of restoration and the tooth surface because of change in temperature. The movement of fluid inside to outside movement of fluid is called as, anyone? So this is called as percolation. The movement of fluid inside to outside because of change in temperature. For which materials this will be more? Materials which are having more difference in coefficient of thermal expansion, there is more chances of movement of fluid. You got it right? You got my concept? So that is the reason why if you're solving dental pulse, you have an old question. Okay. Which of the following has a coefficient of thermal expansion very near to tooth? Which material is having a coefficient of thermal expansion very near to that of the tooth surface, very near to the tooth? Someone is telling. Type 2 GIC. Okay, if, 10 minutes back, someone is telling this answer. Okay, this is what the question is. Type 2 GIC, the coefficient of thermal expansion is 11. And the enamel, the coefficient of thermal expansion is 11.4. So you see, enamel by enamel is 1. Enamel to GIC is 96. Okay, it is having 96%. This is the closest one to have a good coefficient of thermal expansion. Okay, right? Clear? You got it right? The concept. And a very frequently asked question for us is coefficient of thermal expansion is maximum for which of the following materials that are used in dentistry? Coefficient of thermal expansion is maximum for which material that is used in dentistry? Your answer should be waxes. Waxes are going to have highest coefficient of thermal expansion. Got it? So when I'm taking FPD, I told you to return one concept. Okay. I was talking about uh, resin posts. Resin posts, right? You have seen that white color posts that are used in the department. So what is the advantage of using the resin post? The resin post is going to have same properties like that of the dentin. Expansion properties, coefficient of thermal expansion, everything. So that coefficient of thermal expansion and this coefficient of thermal expansion, whatever we are talking is same. And I told you metal posts are going to have more coefficient of thermal expansion than that of the teeth. So that is the reason why whenever you are using metal posts, you have to leave some space. So why you are leaving the space? To expand the metal. Whenever there is a heat, the metal will expand in that space. Whenever you tightly fix them, what is going to happen? Vertical root fractures can happen. Clear? I want you to respond to me, so that I can go for the next topic. Clear, right? You got some ideology now. So next, I want you to jump into Anyway, these topics will be covered by, yeah, we'll be talking about the contact angle. Okay, right? We'll be talking about the contact angle. Contact angle is the angle between the adhesive and adherent at their interface. Okay, so when two things are meeting together, their contact has an angle that is called as contact angle. For two materials to be friendly, okay, so what should be there? The contact angle should be less. So whenever the contact angle is less, that is going to have a better wetting property, better spreading property. So less the contact angle, more the wetting. Less the contact angle, the more the wetting is. Okay, and there is one more two important statements that I want you to make a note. If the contact angle is less than 90 degrees, the liquid is going to raise. If the contact angle is more than 90 degrees, the liquid is going to fall. I told you, less the contact angle, more the wetting property. So ideal wetting property, if they're asking, ideal wetting property, the contact angle should be 0. And all these values which I have listed out here were given in your dental Phillips. Okay. Particularly when I am talking, when I'm discussing, even I have discussed, Akshay sir has discussed. I hope you have seen the videos of impression materials. So when I'm talking about elastomeric impression materials, which elastomeric impression material is hydrophilic? Hydrophilic means water loving. Which elastomeric impression material is hydrophilic, water loving? Water loving elastomeric impression material is polyether. So polyether should have low contact angle or high contact angle. Polyether should have low contact angle or high contact angle. It should have low contact angle. You can see the value of polyether is 96 degrees. Whereas all the other are going to have higher values. It is 82. It is 98. And addition silicon has two types of materials, one with 98 and one with 53. The least contact angle is polyether. So polyether is water loving. Polyether is water loving. The other important things that they have mentioned is the contact angle between the saliva and acrylic. This is coming under prostho. Okay, the contact angle is 75 degrees. The contact angle between the glass and mercury, that will be coming in the thermometers, that is 135 degrees. Okay, so clear, right? So now you got a, for any good impression material, okay, that sets in the presence of water, that is water loving, should have more contact angle or less contact angle. Okay, water loving should have less contact angle. Hydrophobic material should have. Hydrophilic is less. Hydrophobic are going to have more contact angle. So simply they can give a statement. Material A, material B, material C, material D. Upon investigation, we got to know the contact angles of these materials with that of the oral surface, with that of the oral mucosa. So values they have given. So tell me which of the following is hydrophilic. Hydrophilic means among option A, B, C, what you have to select? You have to select a material which is having less value. So I hope you got the concept of this contact angle. Then I'll be jumping into so whenever you read something, okay, again, these are like suggestions. These are not mandatory things. Okay. Whenever you read like something, a content, okay, for example, I'm talking about hardness tests. If you check out the hardness tests in Phillips, the depth is up to 50%. There are many other books like Mahalakshmi is there. Mahalakshmi ma'am has explained hardness tests in a very depth-oriented level. Okay. But what we read, where we read is very, very important. Okay. Because now you have lots of impact of social media. Someone is going to post a question. Your friends may be taking an app where they may prepare a question from Mahalakshmi. I'm not telling a final exam question will not 100% will not come from Mahalakshmi, but to my analysis, whatever I am doing from 10 years, 98% of DM questions are from your dental Phillips. So this is the most standard textbook to prepare a dental materials question. So whenever you want to be perfect in a particular concept, the maximum perfection can be your dental Phillips, not more than that. If you want DM, there are 100 number of books of DM, but logically we cannot read all those books. If you want to be so perfect, like repeatedly going wrong in a particular thing, you want to make yourself strong, you want to read each and every line, you don't want to take a risk. What should be the maximum reference source for a dental material subject? The maximum reference source for a dental material subjects is Dental Phillips Skinners. That's all. There is no question about this. Somewhere your friend is solving some question where question was taken from an XYZ book. Even then, it doesn't matter. It doesn't matter. The probability of that particular question in the final exam is very, very less. Okay. So you keep your subject or you keep your material limited. So whenever you keep your material limited, then you can revise it well. Then you can prepare well. If you keep like where you can swim well, is it a swimming pool you can swim well, or in the ocean you can swim well? My questions are very simple. Where you can swim good? In a pool you can swim good, or in an ocean you can swim good? Yeah, it's very simple. Like in swimming pool we can swim good. The reason is swimming pool has a depth. You know the depth. You know the depth, how depth it is going to be. You know the safety protocols of a swimming pool. But once you're jumping into ocean is undefined. You know that you don't know the depth, you don't know the protocols, you don't know the safety measurements. So you prepare what you want to prepare for, and you try to be in your preparation only. Don't peep into the preparation of your friend or your batchmate XYZ, because their game is there, your game is your. You need to trust the process. You need to trust yourself when you're preparing for an entrance exam. Okay, right? So now we'll talk a little bit about materials, that is your tests. Okay, and I want you to stick on to this number only. This is more than sufficient to answer the questions which are given in the exam. So tests are basically divided into macro and micro. And the demarcation of macro and micro, that most of you are familiar. If I'm talking about force that we are applying, so what is the value of force? What is that value of force? If we are talking about force that we are applying, the value of force is 9.8 newtons. So whenever the value is more than 9.8 newtons, they are macro tests. Whenever the value is less than 9.8 newtons, these are micro. So as I am applying the force, so what I'm doing on the material, I'm creating an indentation. You can see the tools. Every tool is having something which is creating some depth indentation. So again, this macro micro tests are divided basing upon the indentation also. Can you tell me what is the indentation value we have discussed? So indentation value is 19 mm. So whenever this value is more than this, they are macro tests. Whenever the value is less than this, they are micro tests. This is the first thing that you have to make a note. Check out whether they're asking indentation, or check out whether they're asking the amount of force that you are going to apply. And I have given a beautiful code, bar. A for macro, B for Brinell, and R for Rockwell. So these are going to be 9.8 newtons, more than 9.8 newtons. Okay. So Brinell and your Rockwell are going to come. Which type of tests they are? Which type of tests they are? Brinell. Our code is bar. So they are basically macro tests. The other two tests, Vickers test and Knoop's test, are micro tests. So here they have clearly demarcated what type of tool they are going to use. Okay. Okay. So the shapes of the hardness points and the indentation depressions left in the material. Okay. So this measures the M value. Okay. Right. So M value that is shown in the test used to calculate the hardness. Right. So the M value. So you in all the places you have M values. Okay. You see M value is here. M value is here. M value is here. M value is here. So M value is telling you about the depth of indentation. So for example, I take Brinell. B for B. B for B. Brinell is a ball. You can see ball is there. Clear? So Brinell test is a stainless steel ball is used. The diameter of the indentation is measured after the removal of that. Okay. So you can see this is a diameter. M is being measured. So in Brinell, Brinell is made up of ball. B for B, ball. The ball is stainless steel ball. What you're doing, you're measuring the depth of diameter. Clear? The second one is Rockwell. Rockwell, where you can see it is conical. You can see it is conical. So M is the difference between the two penetration depths. M is the difference between the two penetration depths. You can see the difference between the two penetration depths, what you are using in the Rockwell. Whereas coming to Vickers for victory, 1 over 36 runs, 136 degrees, with which you are getting a victory. This is a diamond pyramid. A diamond pyramid is used. A diamond point is used. The longitudinal diameter of the indentation is measured. So the longitudinal diameter of the indentation is measured in the case of 1 over 36 Victor. The last one, NOOPS. NOOPS is rhombohedral pyramidal diameter, where the long axis of the indentation is measured. Okay. Now, if they are giving the diagram of a tool, I hope you can identify them. B for B. So ball is going to present in Brinell, whereas 136 degrees angle is going to be there. Your answer should be Victor's. Okay. And other angles, like for example, 130 degrees or 172 degrees angles are present, then your answer is NOOPS. Now you got a basic idea, right? The difference between the tools that are used in micro tests, the different types of tools that are used in the macro tests. Clear? If you're clear, I'll be going to the next part. Okay. Now, other important thing I want you to make a note, lines from the textbook. We have already discussed about the code BAR, bar. B for Brinell, A for macro, R for Rockwell, where the force is going to be more than 9.8 newtons and depth of indentation will be 19 mu meters. And this is not suitable for brittle materials. This is not suitable for brittle materials. Your macro hardness tests are not suitable for brittle materials. Okay. Whereas your micro hardness tests are suitable for brittle materials. So now my question is, brittle materials, to measure the hardness of brittle materials, what type of tests you are going to use? Brittle materials are basically measured by micro hardness tests. They are not macro hardness tests. They are basically using micro hardness test. Okay, that is one important thing I want you to make a note. The second one is rubber-based materials. Hardness of rubber-based materials and hardness of plastic materials is measured by a different test. You need to make a note of these tests. Okay, this is again a repeated question. Okay, apart from the 4 tests what we have discussed, there are other 2 important tests that you have to make a note. So these 2 tests, Shore test and Bracol test, are basically useful to measure the hardness of rubber materials and plastic materials. Clear? The other important point I want you to add to your notes, which we have already discussed. What is that already discussed? NOOPS hardness test is independent of ductility of the material. Yesterday, we have already covered this in the group. NOOPS hardness test is independent of the ductility of the material. Clear? Clear? Guys, I'm done with the thought of discussing few important concepts. Okay, so DM is going to be dry. I'm repeatedly telling it's going to be dry. So whenever someone is tough, okay, so you have different HWODs. Few HWODs are so friendly to you. Few HWODs are a little bit tough to you. So whenever you have a tough HWOD, what you're going to do? Few subject teachers may be tough. So whenever you have tough teachers, what we regularly do is we give more respect. We read more. We revise more. We take care of that particular subject more. Okay. So this is how you need to handle dental materials. And of course, that's what I'm telling, like throughout the preparation phase, I'll be with you. I'll be with you. Okay. Whenever you feel a little discomfort, whenever you lead a little abnormality with a particular concept or a subject, okay, you can let me know. So I'll try to make it simple in my style. Okay, in my style, I'll try to make it simple. I'll try to give my best to make it as simple as possible and as convenient as possible. Okay, so as of now, I'll be closing the session. We'll meet again one more day for further discussion. And the ProLive students are going to have 2 ProLive sessions. Probably they'll be on Saturday and Monday by Dr. Gauri Shankar sir. Okay. So see you all. Good day. Study well and take care. Anything more apart from this? So as we have already met, if you have any issues related to your preparation, you can just drop me a message. I'll try to address. If it is a common issue, I'll try to address. Anything, guys? Chala, we can close. We can close the session. Okay, then. Right. Bye. Take care. See you. I hope you like the session. Bye, guys.